Okay, good morning everyone. I'm Mr. Samuel Osinde. Mr. Samuel Osinde, I teach chemistry and mathematics. Today I want us to learn about chemistry from two work, which is structure and bonding. Structure and bonding is a topic in Form 2 that deals with attraction between elements and atoms when they bond to each other. And in the process of bonding, there's always a chemical reaction taking place. So we want to look at how does atoms bond. Always we know that when you talk about a bond, you think of a mutual force of attraction between particles. For example, in a family, the bond is the blood that children or siblings share together. So just like in a family where there's a common blood or a common background, chemical atoms can also join together to form some linkages, just like in a family. And therefore, the chemical attraction when atoms react is what we call chemical bond. So I've said that a chemical bond is also associated with chemical reactions, because without a chemical reaction there will be no production of new substances, and therefore bonding involves some transfer or sharing of electrons amongst atoms of an element. The sharing of electrons can be between atoms of the same element or atoms of different elements. Similarly, the transfer of electrons can also take place, especially in metals. So we are going to look at generally how many type of bonds do we have and how do atoms bond when they react. Having said that, I want us to look at a very short concept about bonding or chemical reactions, because we know that in atoms we have got three particles. That is, we have the electrons, we have the protons, and we have the neutrons. The electrons, these ones are negatively charged particles. The protons are positively charged particles, and the neutrons have no charge. The neutrons and the protons are found in the nucleus, and therefore they form what we call the nucleons. The nucleons. While electrons are found outside the nucleus in energy levels, also known as the shells. So shells, this is where you find the electrons. But nucleons are protons and neutrons. These ones are found in the nucleus of an atom. So, amongst the three particles, which one will be the initiator of chemical reaction or of bonding? We all know that for a chemical reaction to take place, there must be a reason for that. For example, when you look at the noble gases, e.g. helium, neon, neon and argon. So helium, neon, and argon. These three elements, they form the noble gases group, and therefore there is a reason why they are classified noble gases. Because when you look at the helium has one energy level, which is full because it has got two electrons. So this one is why we call it a duplet. It has a duplet configuration. While argon and neon, they have 8 electrons without utmost energy level, and that one is called the octet configuration. So both the duplets and the octet configuration are stable configuration, and therefore any other atom which is not in this bracket will try as much as possible to attain this configuration by either losing electrons, gaining electrons, or sharing electrons amongst the bonding atoms. So these two configurations are what makes atoms now to bond, to attain them, because they are stable. And for that reason, noble gases, they are generally unreactive. Generally unreactive. Because their outer shells are completely filled up with electrons, and they neither gain nor lose electrons. Now, we want to look at types of bonding. Types of bonding. And we have one, ionic bonding. I'll explain this. We shall discuss each of them. 2, we have covalent bonding. 3, we have metallic bonding. This will form the main types of bonding in Form 2, and in the high school chemistry generally. We are going to discuss each one of them and see how these atoms will bond to each other when ionic bond takes place, when covalent bond takes place, and when they bond as metals. So let us start with ionic bonding. Ionic bonding. It is important to know that ionic bonding takes place when there is complete transfer of electrons from one atom to another. So there is complete transfer of electrons from one atom to another atom. Remember, when we are doing ion formation, looking at the ion formation, in the first topic, that is the structure of an atom, we discussed that when atoms form ions, they do so by either gaining or losing electrons. And therefore, generally, we say that metals generally lose electrons, and nonmetals, while nonmetals gains or accepts electrons, so gains electrons. That is why when we are looking at ionization energy, we say the ionization energy is basically in metals, while electron affinity is found in non-metals. So from the definition, or from the first point, on how an ionic bond is formed, we have seen that it is formed when there is complete transfer of electron from one atom to the other. So we have to ask ourselves, where is this electron coming from and where is it going? From the behavior of metals, metals have a ability to lose electrons to other substances, and therefore you will find that ionic bond is always between metals and non-metals. So this bond occurs between metals and non-metals. This because the metals will lose the electrons which will be gained by the non-metals, and therefore we have got example of ionic compounds, and we are going to do their structure. So e.g. sodium chloride, sodium chloride. In the sodium chloride, we have got sodium and chlorine atoms, and in this compound, sodium is a metal, chlorine is a non-metal. So we are going to look at how the sodium atom and the chlorine atom will behave when they form ionic bond. So we know that a chlorine atom has got 17 electrons and 17 protons. So chlorine, 17 electrons and 17 protons. Therefore, when you write the electron configuration of chlorine, it becomes 287. 287. That tells you that for chlorine to react, it needs to gain one electron. So gains one electron during a reaction. Let's look at sodium. Sodium has 11 electrons and 11 protons. And therefore, the electron arrangement of sodium is 281. So a sodium atom, for it to form ion or to react, need to lose one electron for it to react or for it to form ion. This one takes us closer to the structure of these two elements, that the one electron which will be lost by sodium is the same electron that is going to be gained by a chlorine atom. And therefore, the ionic bonding will take place. Remember, when sodium loses one electron, it becomes positively charged, while chlorine becomes negatively charged when it gains an electron. So the opposite charges are what will now bring what we call the electrostatic attraction. This is the basic laws of electrostatics, that unlike charges attracts, like charges repels. So when you have two ions that are oppositely charged, one is positively charged, the other one is negatively charged, they will attract each other. There will be some mutual attraction between those two atoms, and therefore there will be some linkage, or there will be a bond which is formed. That is the bond that we call ionic bond. Ionic bond. Because it is attraction between two different ions, two ions of oppositely charges, one positively charged, the other negative charge, there will be some attraction between those two ions, forming ionic bond. So if you are asked to draw the structure of sodium chloride, you will start with drawing the sodium atom, So you have 2 electrons there, you have 8. Then you have the last one, which is being lost. So this one is 2, 8, 1. Then chlorine, so chlorine will be 2 here, use a dot. Then the last one, so this one is 2, 8, 7. So this electron will be transferred into the chlorine atom, and therefore this transfer of electron will lead sodium having now 8 electrons, 10 electrons, and chlorine having additional electron, which makes it now to be 18 electrons. So the structure formed will be 2 ions of opposite charges. So this will give you 2 ions. When this happens, there will be 2 ions of opposite charges. So you'll have the sodium ion So the sodium ion will have now 10 electrons because it has lost 1. So you will have to put a bracket and the charge, which is positive charge. So this one is now the sodium ion. So you have sodium ion with 2.8. It has lost 1 electron. That is why you can see now it has got a positive charge, because now electrons are less than protons by 1. Then you also have a chlorine ion, chloride ion. Chloride ion. Then the visiting electron, which has come from sodium. This one is minus. So you can see there's a visitor here, and this visitor has come from this side. It is this one that has now come to the other energy level of chlorine, and therefore this one is called chloride ion with a negative charge of 288. Now the ionic bond now comes because of attraction between this positively charged sodium ion and this negatively charged chlorine ion, chloride ion. So these 2 ions will now attract to each other. They will develop some mutual attraction, and that is how now this attraction now is what will bring the ionic bond, attraction between these 2 ions. So you can see clearly that when this 1 electron is lost, it is gained by the chlorine atom, and therefore you form 2 ions of opposite charges. So there are so many ionic compounds that you can derive from this kind of bonding. You can also have magnesium oxide, which I want us to draw its structure. So this one is sodium chloride. Sodium chloride. Similarly, you can be asked to draw the structure of magnesium oxide. Magnesium oxide. We know that magnesium is a metal, oxygen is a non-metal, and therefore when they come together they will form ionic bond. So you have to ask yourself, how many electrons that magnesium loses, and how many electrons does oxygen require to form a complete stable configuration? So magnesium is 282. 282, and therefore it requires to lose electrons to become stable. So this one loses 2 electrons to form 2,8. Form 2,8. And therefore magnesium ion will be Mg2 plus. Oxygen is 2,6. So which means that for oxygen to be stable, it needs to gain 2 electrons. And therefore this one gains 2 electrons to become or to form 2,8. But now the electrons are more by 2, and therefore the oxide ion is the O2 minus. This is another oxide ion, So if you're asked to draw the structure of magnesium oxide, you start by drawing so you have first 2 there. Then you have the last 2 electrons somewhere there. So this one is Mg2H2. That's the electron arrangement of magnesium atom. Then you have the oxygen. So this is the oxygen 2,6. That's the oxygen atom. So these 2 electrons will be transferred into the oxygen atom. And therefore, the magnesium atom will become magnesium ion. So you'll have Mg Mg two plus, because it has lost the 2 electrons, so it becomes +2 charged. Then the 2 electrons will be gained by the oxygen atom to form the oxide ion. So you'll have the oxygen this one is 2 minus. So this one is Mg2 plus, which is 2,8. Or 2 minus is also 2,8. This one is the magnesium oxide. That's the magnesium oxide. So you can see how these 2 atoms bond. When now we have got the 2 ions, this is now where bonding starts. When now you have the 2 ions, therefore you see this one is 2 plus and this one is 2 minus. There will be attraction between these 2 opposite charges. And that one is where now the ionic bond will originate. Because of that attraction between the 2 ions, forming an ionic bond. So the 2 electrons lost by magnesium atom is gained by the oxygen atom, forming magnesium ion and oxide ion. And that one is now what you call the magnesium oxide. So when you form bonds, you can end up with a structure. When you form so many bonds, you can end up with a structure. Or when you have bonds in a regular pattern, you can form a structure. And for covalent bonding, we form a structure called giant. For ionic bonding, we form a structure called giant ionic structure. So giant ionic structure is now when the bonding atoms are arranged in a regular pattern, in a repeated.
Objective is that
Arranged in a repeated patterns, forming a giant ionic structure, e.g. in sodium chloride, you'll find the sodium and the chlorine atoms are arranged in a regular pattern, forming a crystalline giant ionic structure. So all ionic substances, they will form a structure known as giant ionic structure. And in this structure, the atoms are arranged in a regular pattern, repeatedly, forming a big structure called giant ionic structure. We shall also look at the kind of structure formed when atoms bond covalently or in covalent bonding. So let's look at, once you have these structures and this kind of bonding, what is the behavior of those substances? In other words, what are the physical properties? Physical properties of ionic substances. So physical properties are things like solubility, melting and boiling points, things like electrical conductivity. So you want to look at how do these substances behave. One thing that you have to know that is most of them are crystalline, so most ionic substances are crystalline. Crystalline means they are in form of crystals, most of them like the sodium chloride crystals, which is the normal table salt we use to add flavor in food. So having seen that most of them are crystalline, especially at normal room temperature and pressure, in terms of solubility, these substances are readily soluble. They readily dissolve in water. And you can ask the question, why? Why do ionic substances readily dissolve in water? This because when you look at this substance, it has got ions, oppositely charged particles. I remember water is a polar solvent. So water being a polar solvent, attracts the opposite charges, attracts the opposite charged ions. So you know that water is the polar solvent. Another one has got some polar end or charged ends, and therefore when you have ions, they will attract to the polar ends of water, and therefore they will dissolve in water readily. So ionic substances will dissolve in water readily because of the oppositely charged ions, which will be attracted by the polar ends of water molecule. Then number 3 is that these compounds, they have high melting and the boiling point. This is called the high melting and the boiling points. And again, this is because of the strength of the ionic bonds. Ionic bonds are stronger bonds, so you'll require a lot of energy to overcome the bonds. So this is also because due to stronger ionic bonds. Due to stronger ionic bonds. So the ionic bonds are much stronger, and therefore you require a lot of energy to overcome them. The next physical property that I want us to look at is electrical conductivity. Electrical conductivity. The electrical conductivity is the ability of a substance to allow electric current to pass through it. And when we are looking at trends across a period in the previous class, we saw that there are two conditions for a substance to conduct electricity. One, one condition for conducting an electric current is that that substance must have delocalized electrons, some free electrons that can move from. Okay. So we are saying that electrical conductivity must involve some particles that are able to transfer the electric current from one end of the structure to the other. And this one is only possible when the two conditions are met. In metals, they conduct because they have presence of delocalized electrons. So, what are delocalized electrons? These are electrons that are free to move from one end of the structure to the other, and they can carry electric current as they move through the structure. Number two is presence of mobile ions. So the mobile ions are the ions that are able to move freely. And remember, we are talking about ionic substances, which means we are dealing with substances that have some ions. But those ions must be mobile. They must be free to move from one end to the other. So, generally, ionic substances will not conduct electricity when they are in the solid state. So, they do not conduct ionic substances. Do not conduct electricity when in solid states. So when they are in solid state, they do not conduct. Why? Why? We say that the ions must be mobile. It means that in the solid state, the ions are not mobile. They are not free to move. So this because in the solid state, the ions are not free to move. It means they are in fixed positions, so the ions does not move within the crystalline structure. But there's good news. When now you dissolve them in water, because we say they are readily soluble, they readily dissolve in water. When you dissolve them in water, the ions will now be free to move from one end to the other, and therefore they will conduct electricity. So when they are in aqueous solution form, they will conduct. Again, when they are in the molten state, when they are melted, molten state is whereby now you take the solid, you heat it until it melts. The ions will also be mobile, they will be free to move. So they conduct when in molten or aqueous states, because in these two states the ions are free to move, so they can conduct, because the ions are free to move. So the ions becomes mobile when they are in the solid, when they are in their other molten or aqueous state. So these are the main physical properties. Most of them are crystalline. That means that they are in solid form or in crystal form under the normal room temperature and pressure, readily dissolve in water. So we have said why they are soluble in water is because of the positively charged ions which are attracted by the polar water molecules. So the polar water ends will attract the opposite charges of the ions. Number 3, we have said that they have high melting and boiling points. This one is also attributed by the fact that they have strong ionic bonds. And when the bonds are stronger, you require a lot of energy to overcome the bond strength. Then in terms of electrical conductivity, we have seen that electrical conductivity depends on 2 parameters. One, there must be presence of delocalized electrons, and this one is possible in metals. This one is possible in metals because metals have got free electrons that can conduct electricity. But now another condition is that in case of ionic compounds, the ions must be mobile. They must be free to move from one end of the ionic substance to the other. But now, for ionic substances, they do not conduct when they are in the solid state. When they are solids, they do not conduct electricity. But they do so when they are in aqueous or molten state. And the reason is, in the solid state, the ions are in fixed position. They are in fixed position and they do not move from one end to the other. But when you melt them, when you melt the ion, the compound, or when you dissolve it in water, the ions will now conduct because they are now free to move. So just for your assignment for the ionic bonding, I want to give a class general assignment here. So you are going to try to draw the structures of these ionic substances using a dot and a cross. So once you assign a dot for one atom, you will assign a cross for the other atom. So you'll say using a dot, so this is assignment. So using a dot, so that's the dot, and a cross. Diagrams. Draw the structure. Of the following. So one is potassium fluoride. So I want us to do this one together. Then I'll give you more work as per this assignment. So we know potassium is atomic number 19 and having a configuration of 2881. That's the configuration of potassium. So we know that for potassium to form any bond or for it to react, it needs to lose one electron. So this one loses one electron. So when the one electron is lost, potassium ion is formed, forming potassium ion with a configuration of 288, because the outermost electron will be lost together with the outermost energy level. Then fluorine on the other hand is 27, atomic number 9, and this one is to gain one electron to form fluoride ion, which is 28 in terms of configuration. So if you want to write the structure of this potassium fluoride, you start with the potassium atom, so in case of an exam, you don't need to draw the atom, but you just draw the ions to give you the overall structure. Because you know the electron will come from the potassium atom and the same electron will begin by the fluorine atom. So in an examination, like the assignment to give you, you just need to draw now the overall structure. You don't need to show where the electrons are coming from or where they are going. So you just draw the potassium ion with 288 and the fluoride ion with 28. So you just draw K. So this is the potassium ion with a positive charge there. So this one is K plus, configuration 288. Then you also draw the fluoride ion, F. Fluoride ion, you draw it close to potassium. This one will have the dots. And the one X electron from potassium. So this electron, which is having the same configuration as the one of potassium, has come from the potassium atom. And therefore you must give it a configuration of where it has originated from. So this one is fluoride ion with 2,8. So there will be attraction between these two ions, because this one is negatively charged, this is positively charged, and therefore that is where now the ionic bond will originate. So this one, the structure of potassium fluoride when they undergo covalent ionic bonding. The second one is sodium oxide with a formula of Na2SO. Na2O. You can see in this particular in this particular compound, you need 2 sodium atoms and 1 oxygen atom. We know that each sodium atom can only contribute 1 electron, but the oxygen atom requires 2 electrons, and therefore that is why you require 2 sodium atoms contributing or losing 2 electrons to the oxygen atom. And that is when there will be complete transfer of electrons and also the stability of the compound form. So that's why we have these 2 here. Because this 1 sodium atom can only donate 1 electron. But an oxygen atom requires 2. So you will require 2 sodium atoms to donate the 2 electrons required. So in this case, you have sodium 281, and therefore it will lose 1 electron. There are 2 of them, so each loses 1 electron to form sodium ion with a configuration of 2,8. So when each of them loses 1 and there are 2, then that will be the 2 electrons that oxygen will use to complete the bonding. So oxygen 2,6, this one requires 2 electrons, gains 2 electrons, gains 2 electrons to form the oxide ion with the 2,8. The oxide ion with the 2,8. So in case of you are asked this in an exam, you just need to draw the ions, but you are going to draw 2 of the sodium ions. So you will start with sodium. So we have 2. So this one has a plus here, but you require 2 of them, so you write 2 there. That's the ion. Then it means that 2 of the same sodium will give 2 electrons that are going to be gained by the oxygen atom to form the oxide ion. So you come to oxygen, but you make sure you use the opposite configuration. Once you use a dot, and next somewhere the other one use a dot. So the oxygen now we dot them, the 2,6, then we cross the electron that has been gained. So this one becomes 2 minus because it has gained 2 electrons. So these 2 electrons has come from 2 sodium atoms, forming 2 sodium ions and 1 oxide ion. So this one now give you the sodium oxide, Na2O. The 2 is this one, and then the oxygen is 1. So sometimes when the number of atoms required are more than 1, it is advisable to draw 1 ion, then you write the number before the ion. It will say that you are reducing 2 of this to give 2 electrons. The next one is magnesium chloride. Let me do it here. Magnesium chloride. Magnesium chloride has got 2 atoms, magnesium atom and chlorine atom. And the formula is MgCl2. So it means that you require 1 magnesium atom and 2 chlorine atoms. 1 magnesium atom will donate 2 electrons. But you know that each chlorine atom only requires 1 electron to become stable. And therefore, that's why the 2 electrons must be gained by 2 chlorine atoms. That's why this 2 is there in the formula. And therefore, You will write the magnesium ion, so you have magnesium 282, so it loses 2 electrons to form magnesium ion with a charge of 2 plus. So the magnesium ion formed here is because of the 2 electrons that has been lost, and now the number of protons are more than electrons by 2. These 2 electrons must be gained by the chlorine atoms, but each chlorine will require to gain 1 electron. That's why we need 2 of them, to make sure that the 2 electrons that has been lost by magnesium is gained by the 2 chlorine atoms here. So this one will give you 288. So this one to form 288, which is chloride ion. So you draw the magnesium ion. You start with magnesium ion. You assign the cross there. And of course, you must have the 2 plus charge, then the chlorine. So, the first 2, the next 8, then you will have this 287, then there's extra 1 minus, but remember we require 2 of this, so you write 2 there. So when you write these 2, then it means that the 2 electrons from magnesium will be gained by 2 chlorine atoms. So there are 2 of these ions. That's what this number symbolizes in structure and bonding. And therefore this, the magnesium chloride. That's the magnesium chloride. So now, having known how to use the numbers here, because once you lose 2 electrons, there must be complete transfer. That is when the ionic bond will be formed. And that complete transfer means that if 1 chlorine requires 1, then you need to use 2 of the chlorine atoms to gain the 2 electrons that has been lost by magnesium. So now you can as well try to also draw and use those numbers appropriately for the following compounds. So we are at C, so I want to start from D. So D, you will do aluminum oxide. Aluminum oxide is Al2O3. So it means that you require 2 aluminum atoms and 3 oxygen atoms. And you know how you can use those numbers once you have drawn the ions. Then, magnesium sulfide, which is the Mgs. So you need 1 magnesium atom and 1 sulfur atom. Then lastly, aluminum chloride, that is AlCl3. So again, this one requires 1 aluminum and 3 chlorine atoms. So that brings us to the end of ionic bond, and I request you to also try drawing these structures at your own time and see whether you have the concept with you, because this concept is very important in terms of chemical reaction are concerned. Now I want to go to the next type of bonding, which is also much easier and direct. which is covalent bonding. Covalent, so this is number 2. Ionic bonding was number 1, so this covalent bonding. So sometimes it is not easy to lose electrons, especially when elements that have the tendency of gaining electrons are involved in a chemical reaction. When that happens, the atoms can decide to share the electrons they have instead of giving out. So when electrons are shared among the bonding atoms, then a covalent bond originates. From the previous bonding, which is ionic, you have seen that there are a group of elements, or there are a group of atoms that find it very difficult to give away electrons. That is the non-metallic elements. The non-metallic elements have a tendency of gaining, and therefore when they are cornered in a bonding amongst themselves, they decide, okay, what we can do, let us share these electrons, because no one is ready to give out. Then a covalent bond arises. So this one is involved sharing of electrons amongst the bonding atoms. So sharing means one atom will give one electron, the other will also give one electron, and therefore they will do so forming not one, not two, but even more than 3 types of covalent bonding for them to become stable. This one is seen in molecules. Seen in molecules. Molecules such as hydrogen, chlorine, oxygen, water, carbon dioxide, etc. So just to draw maybe one, even nitrogen, of these molecules, for example, if we take hydrogen molecule, which is H2, the hydrogen atom always has one electron. So the hydrogen atom always has one electron. So for it to react, it requires to gain one. And in this case, there will be nowhere to gain the electrons, but instead it will share the electrons. And therefore, you will have an hydrogen atom bonding with another hydrogen atom. So the energy levels will overlap, and this one will give 1, the other is also give 1. So you can see now each of them has an energy level with a duplet configuration. Duplet means 2 electrons. So this one will have 2, this also have 2. So the overlap of the energy levels allow them to share the electrons. Covalent bonding, we have said, is the sharing of electrons, especially it is compact mass metals. Remember, non-metals, they have tendency of gaining electrons, but when they are cornered in a bonding or in a chemical reaction, they seem to be sharing rather than gaining, because there is no one who is ready to lose its electrons. And therefore, this one is seen in molecules like hydrogen, chlorine, oxygen, water, CO2, nitrogen, etc. And I've just drawn a molecule of hydrogen here, whereby you have the hydrogen having 1 electron each and 2 of them. So they will share, the energy levels will overlap. You can see there's an overlap of the energy levels. And therefore, where they overlap, there will be some sharing of electrons. And these electrons, once they are shared, a covalent bond will arise between the shared electron and the nucleus. Always there's attraction between the nucleus and these electrons, and also the other nucleus and this electron. So there will be some bonding amongst the 2 nuclei when they share the electron, because each one of them will be trying to attract the bonded electrons or the shared electrons. This is also seen in chlorine molecule, whereby we know chlorine has got 287, But I've said that for covalent bonding, we only focus on the outermost electrons. We don't check on the other electron. Why? Because in the outermost energy level is where the overlap takes place, not the inner energy levels. And it is also important just to represent the outermost electrons only, rather than representing the other one. So for chlorine, we will focus on the last 7. On the last 7. You can see the last 7 of both, they will overlap. This one will give 1, this also gives 1, then they share. Then the other 6, which will be called the lone pairs. The lone pairs, or the unshared pair of electrons. This one will be not bonded to anywhere, and they will be represented in the other space of the outer energy level. So I just wanted to introduce this, but in the next class we shall look at covalent bonding extensively and draw most of these molecules. So make sure you check the assignment on ionic bonding, and also you look at some of these examples even in your books and any other reference materials. Thank you very much, and may God bless you.